Hey, 12 is the next part of our topic on integration. Right, today we're looking at indefinite integrals. The main difference here is that we do not have those bounds, A and B. We don't substitute in here anymore, and we don't get a sort of a neat value at the end. Instead, we get some other expression. We get another function usually. One thing to keep in mind, so that's one thing. Essentially, all we do is we find the primitive. But remember, we have been sort of skipping over this little bit when we've been doing definite integrals, that there are in fact an infinite number of primitives, because if I differentiate a constant, if I differentiate a constant, it disappears. So there's any sort of constant we can put on the end. You're going to see, as we go through these, we put a plus c on the end of our answer. We find the primitive plus c. Primitive plus c. You can say for some constant c, but I think we're probably happy enough that we do it so frequently we understand what that is. Okay, so finding the primitive would seem to be sort of less work than we've been doing in the previous exercises. We're going to look at harder examples as we go along. And the first kind of question we're going to look at is where we have this thing here that's a function of a function. Yep, so you can differentiate these things, function of a function. We need to go backwards. We need to find the antiderivative of this, the primitive. We need to find the integral of this. We need to find the integral of this, and we get a little reminder here of what we do. We raise this power by 1. This part stays the same. We raise this power by 1, and we divide the whole lot by the product of this raised power, the n plus 1, and the coefficient of x. Right? What that means is, don't forget to see in the end, what this means is here that we start with the 3x plus 1. We increase that power by 1 to a 6, and we divide by the 6 times the 3 is 18, plus our constant of integration. Is that okay? Let's try it again. This time we have a negative coefficient of x. That doesn't make our life too complicated. That we have 5 minus 2x. We raise that power from a 2 to a 3, and we divide the whole lot by the 3 times the coefficient of the x. So we divide that by negative 6. Not usually a good idea to have a negative in the denominator, but we can just put it up here, or we can put it over here, or we can have a negative 1/6. I don't mind. Plus, don't forget our constant of integration, like that. So that's the first one we want to look at. We can do the same sorts of things if these were definite integrals. If I had bounds here from, like 3 to 4 or something, that's fine. We have our square brackets we substitute in. We don't care about the constant because they cancel out. Right, but we don't have to do all those things. We end up with an expression rather than a constant. So, next up, let's look at how we integrate functions or integrands with what should be a negative exponent. That's not negative, that's a 3, but it's in the denominator. So we're first going to rewrite that as 12x to the negative 3. Right, so I need to find the integral of this dx. That's what I'm trying to integrate. 12x to the negative 3, well, I increase this power by 1. That's a negative 2, be careful, not negative 4, negative 2. So that's x to the negative 2, and I divide this by this number here. Right, and I get negative 6. Because if I differentiate this, I will get 12, positive 12, negative times negative 12x to the negative 3. Right, plus our constant on the end, that's it, negative. Right, so rewrite it as a negative. We're going to do the same thing here. It's going to be a combination. So this is equivalent to the integral of 3x plus 4 to the negative 2 dx. Right, and the way we do this, remember I start with 3x plus 4. I increase this by 1, so that's a negative 1. And I divide it by this number times, this number by this, by negative 3. We were given this as a fraction, plus our constant. We're given this as a fraction, so we should probably return it that way. Now that gives me, I'm going to say negative 1 over 3 outside of 3x plus 4. There are a few different ways we can express that. We can put the negative up here or down here. I mean, really, this is not wrong. But this is closest to the format we're given the question in. That's usually a good indication of how you should provide your answer. Right, so there's a couple more. I think we might look at the other examples in another video. So that'll get us started. Check over that. They are indefinite integrals. Right. Essentially primitives, including that constant on the end, we don't have to substitute in. Thanks, guys.